Welcome to Style Swipe, where we build your closet one swipe at a time. To get started, open up the app and either sign in with an existing account or sign up using your email and Telegram username. Upon signing in, you're taken to the home screen where there is a deck of cards of items for you to swipe depending on your preference. If you don't like an item, swipe it to the left. If you like an item, swipe it to the right. To see more details about the item, double tap on the item card. Here, you can see more information about the item and add it to any of your collections. You can also either visit the seller's website or contact them through Telegram, depending on if the item is a user-created listing or not. And you can add the item to your cart as well. If you scroll down, our machine learning algorithm automatically shows you similar items, and you can tap on each item image to see more details as well. Items that have been added to the cart can be seen on the cart page, where you'll have the option to either remove items from the cart or choose to purchase it. You can view the collections you've created earlier and edit your personal details by going to the Profiles page. Items that have been swiped right are automatically saved to your liked items collection. Tap on any of the collections you created to see the items stored inside. You can edit your collection by pressing the Edit button at the top and selecting items you want to remove from the collection and pressing Confirm. You can also sort the item by their alphabetical name and search for any items by using the search input bar. To rename the collection, press the pencil icon at the top. You can also change your email or password from the profile page. You can create a new listing for others to see in the Listings page. Simply press on Create New Listing and fill out the form as required. You can also see the listings you have made and delete any of them by pressing on View My Listings. You can also go into the Explore page to explore collections created by other users. Currently, there is a View All User Listing tab where you can go and view all the listings made by other users. You can tap on each of these items to see more detail, just like the home page. You can also go into All User-Made Collections tab, where you can go and view all the collections made by other users. Tapping on a collection name allows you to see that collection in more detail. You can press like on the collection, and even save the collection to your own collections by pressing save, and entering a name you'd like to save the collection under. Let's look at the software engineering principles and practices that went into making this application. We adhere to the single responsibility principle, where each page is broken into components that are responsible for performing a singular task in that page. For example, our home component is made up of a card deck component, responsible for displaying the cards, the item details component, responsible for displaying the detailed item page, the collection menu, responsible for displaying the collections to add an item into, and the new collection form, responsible for creating a new collection for the item to be added into. The next principle we followed was the open-close principle, where each component of our app can have its functionality extended without modification of existing code. One example of this would be the item card component we use in our app. Our Home tab displays an item card component by default, and double tapping on the item card displays a detailed item card component, which shows more information about an item. To create this detailed item card component, we extended upon the already existing item card component by importing it to the detailed item card and adding components around it, without modification to existing code. This helps in creating less lines of code, as existing components can be reused without modifications, and as a result, reduces bugs in our program. It also helps with scaling our code with additional functionalities. We also utilize the facade pattern, where there is a simplified interface abstracting away the complex implementation details of what that interface is doing. To get specific pieces of data from the backend, we need to write complex SQL queries and then determine what happens on data retrieval, failure, or success. Our utility functions hide this detail from its users, which in this case are the components that require these data, and enables the users to simply call and retrieve the prepared data from these functions. This helps in separating concerns and makes the code more readable. All of our components mentioned above have been unit tested. Our React component tests were written based on 3 goals in mind: whether it's rendered properly, whether it displays props passed down to it correctly, and whether it behaves as expected on user interactions. We then performed integration testing for each of our pages so that all the components required to render each page works together properly. Lastly, we performed system testing to make sure different pages work together in one system. We used tools such as Husky and React Native testing library for our front end, and PyTest for the machine learning algorithm to automate our testing process. We used revision control softwares, Git and GitHub, to work on different features at the same time and merge changes without affecting each other's work. This allowed one of us to focus mainly on the machine learning side of the app, while the other focused mainly on the front end and the back end of the app. We forked from the same repository, worked on the assigned parts, and created pull requests every time a meaningful part of the app was completed. When one member creates a pull request, both team members would discuss the changes being made and merge the changes or prevent a pull request if there were issues with it. We also followed the principle of micro-committing, where we would commit changes to our local Git branch every time there was a tiny change. This allowed us to revert back to previous versions of our code if there was a mistake, and fix them without undoing and redoing a lot of work. Lastly, we employed agile development methodology in developing our application. We kept a backlog of features we planned to implement, which were broken down into smaller tasks that were assigned to each person. We then had a 2-week sprint where we worked on those tasks and gave each other feedback on the work that has been done, the goals that have been met, what goals have not been met, and what to do for the next sprint.